Today we're going over lesson 21. So this is going to be transformations of the quadratic parent function. So that parent function is just going to be this x squared. So we're going to work with quadratic functions, how to get them into that form so that we can use them to graph based off of this parent function, and then we'll work from there. So today should be a lot of review, should be a lot of what we did in the past with transformations. Quick something for you to remember. If you have f of x equals, and so for this one I'm just gonna work with here. So let's say we have k, and then we'll have x minus b, and then plus c, and that's squared. So when we're looking at these ones, we're not going to focus on vertical scaling. Vertical scaling is kind of, it's difficult to see, and you really don't focus on it a whole lot. Or not vertical scaling, horizontal scaling. Horizontal scaling, when we made it bigger and wider sideways, we're not going to see that a lot, so we won't worry about it with this one. We will have vertical scaling. If you remember on the outside, that's where you're going to have your vertical. So this k on the outside is your vertical scale. So this should be a review. And this c on the outside, the plus c, that's going to be your vertical shift. So if this is a negative, this c is a negative, then we're shifting down. If it's a positive, we're going to be shifting up. So on the inside here, this is always what we have as our horizontal. So like I said before, we're not going to have the horizontal scale change, but we are going to have our horizontal shift. So we have the horizontal shift, and that's going to be this b here. Something to keep in mind, if this is a positive, like when we're writing it out and it looks like x plus 2, we're actually shifting to the left 2. When it's x minus 2, we're shifting to the right 2. It's a little bit backwards, but that's just something that we're going to have to remember when we are working with them. So I would write this down just so you have a point of reference to come back to, and then we're going to go on to example 1. So for letter A, it says a quadratic function is defined by g of x equals 2x squared plus 12x plus 1, and it says to write this as a completed square and show all the steps. So what I want you to do is just work on that one, just some more practice with completing the square, and you're only going to work on one side. Don't move it to the other side. So you'll take this one, move it out to the side, and then keep on working with it. So practice that, and then I will come back and work with you on it. Okay, so I worked it out a little bit ahead. So the very first thing we're going to do is we're going to move this one out to the side, and then we'll group these two on the inside. So then the next thing we'll do is, since we need this front number to be a 1, the leading coefficient to be a 1, we're going to pull out the 2 from each of them. So pull a 2 from the 2x squared and a 2 from originally the 12x. So now we'll have x squared plus 6x, and we'll still have this plus 1 on the outside. So to complete the square, we can use our box here. Put an x squared, x times x will give us x squared, x times 3 will give us 3x, so we have a plus 3, x times 3 will give us 3x here, and then 3 times 3 will give us this 9. So that's going to be the number that we're going to add on the inside. So you remember, what we add on the inside, we have to do the opposite 2 on the outside. But for this one here, when we add the 9 here, we also have to multiply it by the 2. So that would be 18. So subtract 18 on the outside. So the last thing we have to do then is to simplify. So this right here, that's going to come as x plus 3 times x plus 3. So it'll be x plus 3 squared. And then on the outside here, 1 minus 18, we're not going to have a negative 17. So that would be it for that one. So the next part, where's the vertex of the graph of this function located? So if you remember last time, we talked about the vertex form. So when we talked about the vertex form, we could use these two here to help us figure out the vertex. So our x coordinate is the 1 on the inside. So when we do this, we don't take this 3, we have to take the negative version of it. You can also think about what could you plug in for x that would make this inside 0. That's another way you could think of it. So if we want to make this inside 0, we'd have to plug in a negative 3. So negative 3 is going to be our x point. So then we'll have negative 17. That will end up being our y coordinate. So we just take this point right out here, that's our y coordinate, and then we take the negative version, or sometimes if it is the negative version, we just take the number, and that is our x coordinate. So where is the vertex of the graph located? It's at -3, -17. So look at the completed square form of the function. Can you name the parent function? How do you know? So when we look at this, what would be the original function that we had? We have f of x equals x. That's one. That was our line. We have f of x equals absolute value of x. That was when we worked with in the past. And then we also had this one. F of x equals x squared. So when we're looking at this, these here aren't going to be absolute values, so we're not going to have this one. They're also, that x is not just a linear x, so we wouldn't have this one here either. This is going to be x squared, so it's going to be this parent function. So it's f of x equals x squared. It is quadratic. How do you know? Kind of like how I just walked you through that for this one. This x is squared, so we're going to have a quadratic function. This would be our parent, our base function. So what transformations have been applied to the parent function to arrive at function g? Be specific. So with this one here, this is when we're really going to use this top part right here. So from here on the vertex form, we can say, okay, there's a 2 on the outside. So this 2 on the outside goes with our vertical scaling. If it's a positive number and it's greater than 1, this means it's going to be growing. So we have a vertical scale growth by a factor of 2. So the vertical scale increase. Then the next thing we're going to look at is this horizontal shift. So the horizontal shift then we have 3, but this is going to end up being -3 because this one originally would be a negative, so we need to take the negative version of this one. So when we are doing this, we're moving to the left 3. So left 3 units. And then the last one is our vertical shift. Our vertical shift, we just take the number on the outside. So we're going to also say we went down 17. So down 17 units. And we could also put shift, left, shift, down 17 units. So how does the completed square form relate to the quadratic parent function? This is the really nice thing about completing the square. This is another way that we can use the graph. If you remember your parent function, then you can base it off of that. So for here, in the completed square version, it has all those transformations laid out. On the inside is going to be the horizontal, on the outside is going to be the vertical shift, and then in front will be the vertical scaling factor that we're changing by. So that's kind of what I would say there. You can choose what to write down for that, but it does. It shows everything there that we want to see in a change, a transformation, and so it just makes it really handy, nice to work with. Okay, so example 2. The graph of the quadratic function f of x equals x squared has been translated 3 units to the right, vertically stretched by a factor of 4, and moved up 2 units. Write the formula for the function defines a transform graph. Okay, when we are working with these, something that we didn't really worry about too much in the past is the sequence in which it's doing this, because the sequence is very important. If, for example, we said, okay, it's going to be translated 3 units to the left, and then we said it was moved up 2 units, this stretched by a factor of 4, could end up impacting this 2 units up. So that's just something to keep in mind. For these ones, when we're working through these, they're always going to be in an order where you can just kind of add them. So the very first one, we've been translated 3 units to the right. So we'll put f of x, that's going to equal x something squared plus something on the outside. Okay, so if we're going to the right, then we need to have the negative version of that. So it would be a -3. So we just leave that negative. We're going to the right, so that's going to be a +3 here. So we have a -3. Okay, then it's vertically stretched by a factor of 4. So the vertical stretch is going to be right here in the front. So we'll just put a 4 right in front of that. then it's moved up 2 units. So that's our vertical shift on the outside. So then we just put a +2 on the outside here. And it's as simple as that. That would be all that we would need for this one. Okay, so on exercise 1, I'm going to give you guys a chance to work on this, and then I'll come back and show you the graphs of them. You work on these. The biggest thing is these ones are all in completed square or vertex form. These ones are not. So what I would do is I'd complete these ones, graph them. Those should be fine using the transformations. But then these two here, you're going to have to complete the square and then use that to figure out what exactly is going on. So take a moment, graph those, and then come back. Okay, I've gone ahead and graphed a couple here. So for h of x, or g of x, sorry, the first thing I did was I found the vertex. So I found -3 and 4. This one is going to be moving to the right 3, and then we're going up 4. You could also use the vertex form and the knowledge we worked with last time to say it's 3, 4. That would be your vertex. So you put your vertex there. Then your scaling factor in the front. Couple things to keep in mind. If it's a negative, then we're flipping it. It's now going to go down. So instead of it opening up, it's going to open down like this one does here. The other thing is you can look at this right here, your 1 and 2 for your x values. And normally if you did x squared, it'd be 1 times 1, so you get 1 as your y value. If you do 2 squared, you'd get 4 as your y value. So you can kind of use that to get a couple points of reference. So what I did here was I did 1 would be 1. So I went 1 away. Normally we would go 1 down when this situation, since it's a negative, but it's going to be 1 times 2, so I go 2 down. And then I'd mirror that on the other side. And then when I went 2 away, normally I'd go 4 down. But I need to multiply this by 2, since this is a -2 in front. So we're now going down 8 from our original vertex. So that's how I use it to graph this. And then I did the same thing for B. So on B, I found the vertex. It's at -5, 1. Or I use my translation. This +5 means we're moving to the left 5. And the +1 means we're moving up 1. So then the next thing, you have the -3. Again, it's a negative, so we're going to be opening down. And for this one here, it's pretty low. You really only can get 1 over and down, or 1 point away from your vertex x-wise. So that's where I stopped here. So you can just continue drawing the lines. So originally, if you plug in 1 for x, you get 1 for y in the parent equation. So I moved 1 out, and since it's a negative, I'm going to be moving down, but I need to move 3 down since it was a -3. So it'd be 1 times 3, and you get this point down here. So you'd have to move down 3. And then you just mirror that, and then you create your graph. If you wanted to, you could always go in and plug in -4, -6 into this and see exactly where the points would be. That's completely fine as well. So then for C, for this one here, our vertex is a -4, -3. So we're moving to the left 4, 1, 2, 3, 4, and then we move down 3. So 1, 2, 3. So we're right down here. Okay, so this one is a positive number in front, so we're actually going to open up. So for this one here, it's again a 2, so we need to change our scale factor. So for this one here, when we have 1, we go out 1, we normally go up 1, but this time we're going to go up 2. And the same on the other side. So you can mirror those. And then again, when we go out 2 from the vertex, we normally go up 4, but now we're going to go up 8. So we have, that's 4, and we go 1, 2, 3, 4, and we're up at 8. So then just mirror that across to the other side. Okay, and then you can draw your line and keep going from there. So for these last two here for D and E, I went ahead and did the completing the square. So for this one here, you'll just break it up like we have with completing the square in the past, where this one actually doesn't have anything on the outside to take or push out. So we just have x squared minus 2x, and then we'll complete the square. So x squared minus 1x minus 1x, we took half of this one, split them between the two. So we have x minus 1 on the outside, x minus 1, -1 times -1 is a positive one. So we're going to put plus 1 here, and on the outside we'll subtract 1. So then our completed would be x minus 1, that's our sides, and that's squared, and that'll be minus 1. So for p of x, we have moved 1 right, but we've also moved down 1. So we will be right there. So now what we'll do is we can actually use these kind of measurements exactly. So at 1, we move, if we move out 1, we go up 1. If we go out 1, we go up 1. If we go out 2 from the vertex, we go up 4. So out 2, up 4. I don't think I counted that right. So up 4 is going to be right here. And then we can just draw it. So, comes down, goes through that point, and back up, and there it goes. So then this one here, that is going to be p of x. So for the second one here, for e, or t of x, this one's going to be the exact same completing the square. So we push out the 3 to the outside, we add 1 on the inside, subtract 1 on the outside, and we have x minus 1 plus 2. So this one here, our vertex is going to be, we go over 1, but we're going to go up 2 this time. So then the next part is, we can again use these here. So when we go 1 away from the vertex, we can go up 1 on both sides. When we go 2 away from the vertex, we can go up 4. So 2, 3, 4. And then we'll mirror that. So we'll come down, draw this one, bottoms out, and comes back up. And that would be our t of x. When you are working on your homework, you are going to have to do this where you're going to have to manipulate and complete the square there. That way you can graph it using the transformations, and that should make it a little bit easier for you. Okay. Moving on to the next one. So for 2 and 3, I want you to work on both of these on your own, and then we'll come back and I'll help you with them. So on 2, you're going to write out the formula and then you're going to graph it. And then the next part on 3, you're going to complete the square and figure out what the transformations would be. So work on those 2 on your own, and then I'll help you with them. Okay, so for these ones right here on 2, so this first one here, we're going to shift 2 units to the right. So we have f of x, that's going to equal, we have the x. So if we're going 2 to the right, or 3 to the right, then we have to put minus 3. So then the next one, it says as the vertical shrink by a factor of 0.5, so we'll put that on the front, 0.5. Then it's going to be reflected across the x-axis. So for this one here, we'll put a minus sign in front of the 0.5. That's just something that we talked about before, and we actually saw it a lot in that last exercise. So the last one here is it's going to shift up 4 units. So we have a plus 4 on the outside. So the next part is graphing this. So let's see, we're going to be on 3, 4. So I'm going to start it down here, and we're going to open down. So I'll actually put it up a little bit higher. So make your axis. You can kind of choose where you're going to do that. I'm just going to go by ones. That's it. So for this one here, our vertex is going to be at 3, 4. So, or we can think about this, if we shift 3 units to the right, 1, 2, 3, then we go up 4, 1, 2, 3, 4, that's our vertex. So again, when you have x and your y, your parent, so the f of x equals x squared, you're going to get these as your answers. So if you plug in 1, you would get 1 times 1 is 1. So if you were plugging 2 for your x, you get 4, and 3, you get 9. So for this one here, the scale is 0.5. So we're going to have to do, if we go out 1 from our vertex, since it's a negative, we're going to go down half of 1. So it would be 0.5. So out 1, down a half. Then the next one here, we go out 2, we're going to go over 4. So, we go out 2, we'll go down 2. So out 2, and we'll go down 2. Out 2, down 2. So for this one here, that's going to be because we take half of this 4. That's our scale factor here, and we'll end up getting this out 2, down 2. So this next one here is going to be 9. Half of 9 is 4.5. So we'll go out 3 and down 4.5. So down 4.5. Out 3, down 4.5. So again, you should get a mirroring effect. So then you'll draw your parabola, and it'll just keep on going, and you can just draw it so that it keeps on going. So that's all you'd have to do for graphing for that one. So then for 3 down here, describe the transformations of the quadratic parent function. So for this one here, our parent function is going to be x squared, and then this is going to be our new equation here. So the very first thing we have to do is, just looking at this, we're not going to be able to see the transformations. So we need to set this up in vertex form. So we're going to have 2x plus 4x, and then we'll put this plus 1 on the outside. That's how we're going to be working with these. So in order to complete the square, sorry, that's x squared. To complete the square, we need this one up here to be a 1. So we're going to pull out 2 from each of these. So we have 2, and we'll have x squared plus 2x plus 1. So that's where we are right now. So then we'll complete the square. You can use the box. That's completely fine. So we have x squared, you take half of 2x, the split between the two, and then we'll figure out what this last term is here. So we have x times x will give us x squared, x times 1 will give us our 1x, so that's a positive 1, and then x times a positive 1 will give us this 1x here. So 1 times 1 is going to end up being 1. So we're adding 1 inside. So what we do on the outside then is we do 2 times 1, that's going to be 2, and we subtract it from the outside. So we have negative 2. So then we can condense this down into our vertex form. So we have 2 on the outside, this will be x plus 1, that's squared, that's this factor down, and then it's going to be minus 1. 1 minus 2 is going to be negative 1. Okay, so what were the transformations that occurred? So we can just go left to right, or we can go horizontal first and vertical. For this one, we'll just go horizontal first. So we'll look inside. So inside, we had a horizontal shift. So this one is a plus 1, so we're moving to the left. So horizontal shift to left 1 unit. We'll also talk about our other shift here. So we'll have our vertical shift is going to be down 1 unit, and our vertical scale is increased by a factor of 2. So looking here, we'd have our 3 different changes. We had a vertical scale change, we had a vertical shift change, and a horizontal shift change as well. So this is what you want to do here. And again, if it's not in vertex form, then we're going to want to put it into vertex form to work with it. So the last one, on 4, we're not going to do it. It's effectively the same thing as what we did in exercise 1. So we're not going to end up redoing it. If you want to, you can go ahead and have some extra practice there, especially with these ones when you're completing the square. But when you're working on your homework, that's what you're going to be working with. If for some of them, if it's not in completed square version, just like here, this is in standard form, you need to put it into the vertex form or the completed the square form. So you have to work that out so then you can see the transformations and graph from that. You can always then go ahead and once you figure out where your vertex is, plug in a couple of numbers next to it, see what the points would be, that's fine, but definitely work on that graphing wise. Other things, when you're working with these, you can use a graphing calculator to check yourself, but do not use it when you're graphing these. It is really just shorting yourself and you're not able to fully go through and practice these. So Other than that, though, that's all I have for lesson 21. It should be a lot of review, using things we used in the past, completing the square, and our knowledge of transformations. So if you don't have it, I would definitely have this written down, just kind of as a quick guide to go back to. But that's all I have for lesson 21.